Good morning, everyone, classmates and brother Mauricio. In this opportunity, we are going to talk about the properties of liquid. So, without further ado, let's begin! First, what is a liquid? A liquid is a substance that flows freely, but is of constant volume, and its consistency is like water. Okay, my friends, I think that most of you, the first thing that comes to your mind when you hear the word liquid is water. But let me tell you that liquid is not only water. It can be soda, it can be oil, and it can be even honey. But why honey? You will see that later. Did you know that liquids have characteristics? Some of the main characteristics of liquids are that their molecules are pretty close to each other, and because of that, they doesn't have a lot of space between them and they cannot squeeze closer to one another. They have fixed volume but doesn't have a definite shape. Liquids flow from higher level to lower level. Okay, some properties of liquids are capillary action and contact angle. Capillary action is the ascension of liquids through slim tube, cylinder or permeable substance due to adhesive and cohesive forces interacting between the liquid and the surface. And the last one is contact angles. It's one of the common ways to measure the wearability of a surface or material. Now, the three main variables that determine whether a liquid possesses capillary action are cohesive force, surface tension, and adhesive force. Cohesive force, it is the intermolecular bonding of a substance where its mutual attractiveness forces them to maintain a specific or a certain shape. The surface tension occurs as a result of like molecules bonding together to form a somewhat impenetrable surface of the body of the liquid. And last but not least, the adhesive force, when forces of attraction between unlike molecules occur. In a few words, it is the attraction of different types of molecules. An example of adhesive force is when you put some water on a glass, you drink it. Did you realize that after you drink all the water and the glass is empty, there are some particles of water on it? That's the adhesive force. And lastly, we have the contact angles. A contact angle is an angle that a liquid creates with a solid surface or capillary walls of a porous material when both materials come in contact together. There is another definition that is called the traditional definition that states the angle a liquid creates with a solid or liquid when it is deposed on it. The contact angles state that the smaller the contact angle is, the cohesive forces are weaker than the adhesive forces of the molecules of the liquid. And the larger the contact angle is, the cohesive forces are stronger than the adhesive forces of the molecule of a liquid. Now, my partner Swemi will talk about unusual properties of water and the viscosity of it.
Properties of liquids. It's another type of full property defined as a liquid resistance to flow. Unusual water properties, with 70% of our Earth being ocean water and 65% of our bodies being water. It is hard to not be aware of how important is it in our lives. Unusual water properties are six: boiling point and freezing point. The Celsius temperature scale was defined until 1954 by 2 points. Surface stations, heat evaporation, and vapor pressure. Water has the higher surface tension of all liquids. Water also has an exceptionally high head uh, evaporation and vapor pressure in inversely relating to intermolecular forces. Water has very strong intermolecular forces. Viscosity and cohesion. Viscosity is the property of a fluid that has a high resistance to flow. And cohesion is molecular forces between similar molecules. Solid states. All substances, including water, become less dense when heated and denser when cooler. So if the water cools, it becomes denser and forms ice. Liquid states. Water is liquid at room temperature, so I can move faster than when it is solid. And gas state. When water boils, its hydrogens bond break. As you can see in the following table, the boiling and freezing points of water allows molecules to boil or freeze very slowly. This is important for ecosystems that live in water. For example, in the table, the boiling point of water is 100 degrees Celsius and the freezing point of water is 0 degrees Celsius. Viscosity. Viscosity can be not only a fluid's resistance to flow, but also a gas resistance to flow, change, shape, or movement. Viscosity is a liquids that move slowly and are highly viscous are known to be viscous. An important fact is viscosity of liquids and gases are affected by temperature. The opposite of viscosity is fluidity measures the ease of flow. Examples. Oil motor has less viscosity than honey. Glue has more viscosity than blood. Other examples are antibacterial gel paints, the ones that is used to color houses and even making paintings.
The cohesion and the addition. First one, we're gonna talk about the cohesion. The cohesion is the ability of water molecules to be attracted to other water molecules, which allows water to be a sticky liquid. Hydrogen bonds are attraction or electrostatic forces caused by the difference in charge between slightly positive hydrogen ions and other slightly negative ions. One example of addition is when many raindrops can join together and form a large body of water. And after that we have the addition. The addition refers to the tendency of water molecules to be attracted to other substances. This is a result of the covalent bond between the two hydrogen atoms and the one oxygen atom in the water molecules. In a covalent bond, the electrons of the bonded atoms are shared. And from the example of cohesion, we can take when so many water drops stick to any object like glasses or leaf or trees. And then we have the force tension. The source tension is the energy of work required to increase the surface area or of a liquid due to intermolecular forces. And I don't know if you are seeing some little insects that can walk in the water. That's because that little insects don't are too heavy and don't break the surface tension. That's all. And now my classmate will gonna present the rest of the presentation.
Okay, now I'm going to talk about the properties of water, vapor pressure, and wetting agents. Let's start with vapor pressure. First, what is vapor pressure? The vapor pressure is a pressure that the vapor exerts on its liquid state when both are in dynamic equilibrium. The dynamic equilibrium occurs when the two reservoir processes occur at the same speed. Now, wetting agents. A wetting agent is any component that makes it easier for a liquid, in our case irrigation water, to penetrate to solid surface more easily. Strong declares in the surface tension of the liquid and the attraction of water towards to the solid particles. Strong mechanisms of their compressions, such as polar attraction. There are many different modes of action of this, and therefore for the right choice, their mechanism of action must be understood. Thus, there are different surfacts or Khalid surfacts. Now, the following are: 1. Anionic. They are negative charged. They generally moisted. 2. Noic. They are polyiodenylamine surfacts and block polymer surfacts. Now, let the rest of my classmates talk about the rest.
Today I'm going to talk about pressure in liquids. Pressure is the force per unit area that is applied to the surface. In the physical science, the perpendicular force per unit area, or the stress at a point within a confined fluid. The equation. Pressure. The pressure in fluids can be calculated using the following relationship. Pressure is equal to force dividing area, and area is equal to force dividing pressure. Pressure is a scalar quantity. The SI units, International System of Units of Pressure, is the Pascal or Newton per meter square. From the SI units, the unit of pressure is Pascal, which is equal to 1 Newton per square meter. International System of Units, International Decimal System of Weights and Measures derived from extending the metric system of units. Area and pressure. If the area of contact decreases, the pressure increases. Pressure is inversely proportional to area. That is why pressure increases on decreasing area. That means that they have an inverse relationship. Force and pressure. Force is the effect caused by the interaction of two objects which tries to change the state of the object. The pressure is the force acting on an object in the perpendicular direction to the surface of the object, which results in the spreading of force over a certain area. This also means that they have a direct relationship. That's all for my part. Thank you.
The biblical application is on Isaiah 43:2 that says, "When you go through deep waters, I will be with you. When you go through rivers of difficulty, you will not drown. When you walk through the fire of oppression, you will not be burned up. The flames will not consume you." The first part says that even though we're passing bad situation, God will always be with us. No matter what, and no matter where, God will always be with you. He's your friend and won't abandon you. This is the biblical application because they used waters, that is a liquid, to represent that. Okay, that's all for today. Thanks for your attention and God bless you.